yeah, everybody who can keep an eye out for people who are joining. So let me get this off my screen. Do, 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 do. All right, so welcome to the January 2022 CFAS general meeting. Yes, we are virtual again. Obviously, this was not obviously not the plan at the Christmas party. Planetarium is closed this month. We're just going to play it by ear. We're not going to promise next month. We're just going to play it by ear. So keep your ear to the tracks on Groups.io and Facebook and all other social media outlets. And we will decide next month, depending on how things go, as to whether we can meet in person again. Believe it or not, we are nobody wants to get back to in person more than we do. We promise. And we do have some outdoor events this month that we will be doing. So I'll talk about that in a couple of minutes. We have a great program for you tonight. After some announcements and events, our own Anna Metke is going to be talking about space dirt. She is a space dirt professional, and she'll tell you all about that in a little bit. Derek is going to highlight member astrophotos and sketches this month. I'm going to spend a minute, maybe two, on the moon this month. Elaine Fisher is going to report on her adventures to see the solar eclipse in the Antarctic. I'm very excited about that. Derek is going to do one of the things he does best, What's Up This Month, as a planetarium director, of course. And Eric Hoin will spend a few minutes on the sun. And finally, we'll have some outreach news from Mauricio. So just a reminder, official CFAS discussions are through Groups.io. I have changed this slide a little bit. For inter-CFAS communication, chats, and so forth, we are the official platform that is Groups.io, not Facebook. We are on Facebook, but it's not the preferred means. Now, official CFAS news will come to your direct email, not via Groups.io necessarily. So make sure your email address of choice is on file with our membership chairman. And those emails will come straight from our publicity chair, Sharife. And you don't have to use the same email address for both Groups.io and, of course, your notification in case you want to set up some fancy filters. For those of you watching via our YouTube, you can join the Central Florida Astronomical Society via our website. And big thanks and shout out to Frank Kane, our IT expert extraordinaire, for getting our events pages working again, so that things we post on the calendar automatically show up on the front page for public, so that they know what's going on with the club. And Sharife is our publicity chair. Again, she's always looking for astrophotos. So just a reminder, not just astrophotos, but also if you take some pictures at an event, Christmas cardy pictures, you catch somebody doing something embarrassing with a silly hat, or it looks really great next to their telescope, send her a photo so that she can use it in our social media stuff. Speaking of outreach, we have a new outreach chair. Mauricio Moreno is now our outreach chair. We want to this guy here. Pay no attention to all those other happy people, of course, in the photo. I'd like to thank Lynn Ward from the bottom of my heart, on behalf of the rest of the board, for his many years of service to CFAS. I've said it before, I'll say it again. He's one of the hardest working members of the board. And Mauricio's got some big shoes to fill, but I think Mauricio will do fine. I've seen him with the public. He's a natural. He's got a lot of enthusiasm. We'll try not to burn him out. Speaking of outreach as well, last month at our outreach recognition, David Murray got left off the list. We're very sorry about that, David. That's potentially mortifying, but we'll have in fact, he did an outreach event with over 200 kindergartners and first graders, which I've done a couple of Halloweens where I've come back in the house crawling and crying on the ground. So I can only imagine that, but we'll have a pin and a certificate for you, David, at the next time we can all get together in person again. Things going on this month. Let's see, we're going to have Observe the Moon Night, January 15th. That's actually this Saturday, 6 to 10 p.m. And a week following, also on Saturday night, we're going to have our own Winter Star Party. The Winter Star Party in the Keys this month was, of course, canceled for the same reason we're meeting Zoom. In fact, there've been several events that I was originally planning to go to that were canceled in the next couple of months. So we're gonna have our own Winter Star Party. Both of these events are in the parking lot next to the planetarium. They are open to the public. These are technically outreach events, and CFAS is going to crash Derek's. I mean, we're going to support Derek's party by showing up and bringing some telescopes. If you don't have a telescope, feel free to come anyway and mingle. Come and see what all the activity. You know, it's a great chance to socialize. The moon is one of my favorite targets to look at. It breaks my heart that I have a prior engagement that evening, but I can almost guarantee there will be another Observe the Moon night because I'm just so jealous, and we'll just do another one. Presidential prerogatives, right? All right, and that is enough for me, at least for right now. I'm going to turn this over to Tricia, who's going to introduce our main speaker, and then we'll follow up with our mini programs. After that, Tricia, I'm going to stop sharing my screen. Take it away.
Okay, can you guys hear me okay? I'm on mobile.
I hear you great.
Okay, perfect. Okay, so most of you guys know Anna Metke. She's been with CFAS for several years. She's held several board seats. She actually held the seat that I currently hold, vice president. So Anna has been with us for a very long time. Most of us know her. If you have not met Anna, make sure to meet her at a public event, hopefully sooner rather than later. So I'm going to tell you just a little bit about her and then hand it over to Anna. So Anna is Director of Operations at the Exolith Lab, where she facilitates the development of simulated space resources. She focuses on building her career to aid the development of a sustainable space economy. Anna's background includes 9 years of experience working in business management and 4 years of experience in scientific research. Anna has a bachelor's degree in business and continues her education in the physical sciences. She began her journey specializing in deep resources with Deep Space Industries, where she aided in simulant production and business development. Anna joined the Exolith Lab team when Deep Space Industries incorporated into UCF. With a passion for science as well as art, she has spent several years participating in science organizations and STEAM outreach programs to encourage young enthusiasts. She also runs a small business where she shares her enthusiasm for space, art, and nature. When she is not at the lab, Anna enjoys travel, hiking, and cooking. So without further ado, let me hand it over to Anna Metke.
Hello, everyone. Thank you, Tricia, for that generous introduction. Let me go ahead and share my screen and get started. Okay. All right, so it is really nice to be here with everyone. Unfortunately, we can't all be at the planetarium together, but I think that's gonna be okay because this way we can all be safe and I can just pretend that you guys are all laughing at my jokes. So today I'm gonna talk to you guys a little bit about my journey to Exolith Lab and some of the things that we've been doing there lately. For those of you who don't know me, my name is Anna. My professional background is in business development and organizational management and leadership. I've been doing research at UCF for over 6 years now. I've worked at all kinds of projects, mostly spaceflight projects and methods of developing a sustainable space economy. I love science, math, astronomy, all those boring things. So I've been gladly giving my time to various nonprofits over the last decade or so. But of course, as you all know, CFAS is definitely my favorite. So a little bit about me outside of work. When I pretend to have free time, I like to travel, go hiking, kayaking, and pretty much anything in nature. I also enjoy some sports. I like to go running, dragon boat racing, aerial dancing, and whenever I have leisure time, I pretend I like to play video games. Just not enough time, as you all know. So to start off, I'd like to talk a little bit more about my research journey at UCF, because after all, this is kind of what got everything started. So I began my journey during my undergrad, and I started doing volunteer research at a material science lab. After a few very grueling months and tedious labor, I was able to move into a paid position, luckily. I did some work developing flexible scaffolds that were doped with stem cells. I worked on a few other projects, including a project on Parkinson's to create a drug that was for the FDA, and some electrochemical sensors as well. So I later started working at the Center for Microgravity Research at a lab. This is a lab at UCF. I worked on a few different projects, mostly doing manufacturing and assembly of hardware. This over here that you're looking at is a project called Strata, where we studied the stratification of asteroid regolith in microgravity. There are several versions of this project, and some of them went on like short space flights, and others spent long periods of time on the ISS. I spent a couple years working on a small satellite that studied electrostatic discharge events on different on different spacecraft paints. So the goal here was to understand how we can improve the coatings on certain spacecraft to prevent things like electronic failures in the space environment. So DIMS is actually my favorite project of all time. It has been going very smoothly. There have been no problems along the way. The launch dates were never changed. There were never any rocket complications that caused us to delay our flight for over a year. Nothing like that, no problems at all. It's been smooth sailing. So it's been a great project to work on. That is 100% sarcasm, but let me tell you a little bit more about it. It is a very exciting project. It's made up of a lot of components. All of them are very high tech and expensive. Most of them were carefully developed by our collaboration team in Germany, so big kudos to them. The goal of this experiment is to simulate dust clouds with known materials. So when we observe them in outer space, we can have a better idea of what they're made up of. So the image in the middle is actually the payload before it was shipped off to meet a sim Blue Origin at the launch site. So if you're thinking, wow, that looks messy. Yes, absolutely, it is messy. Welcome to space. Everything we do is messy. It's like a very delicate game of Tetris that you have to replay about 25,000 times, but don't worry, I promise it gets more rewarding every time you do it. So what is space research really like? Just to kind of give you an inside view. It is very inspiring. It's extremely educational. You get to work with real life hardware that goes into space. That's crazy. Every project contributes to humanity's understanding of the world around us. So that is very rewarding. You learn something new every day. You get to face new challenges every single day. You get to slave your entire heart out, your soul, you sacrifice your health for the sake of science. Totally worth it. It definitely never gets boring, I'll tell you that. It's definitely a lot of fun. My team is hands down the most favorite part of my job. I get to work with some of the weirdest, funniest, quirkiest, and most creative people that I've ever known. We love to make each other laugh. We have to keep things lighthearted because otherwise you just want to cry all the time. So it's really good to have a good lighthearted team. So like I said, it can be rough at times. It can be definitely very brutal and very hopeless, especially when things with your launch provider aren't going exactly smoothly. Equipment failures is something that we deal with on a regular basis. We basically just eat that for breakfast. We just roll with the punches every day. We just go in and brave new challenges with a smile. So I do have to give my hats off to my team, very dedicated people. It takes a lot to stay motivated, I'll tell you that. So especially at Exolith Lab, it's definitely very dirty. But let's be honest, that's a big part of the fun. We're lucky enough that dust has chosen us to become one with us. So we get to take it home. We get to share it with our families, our friends, our pets, our showers, our carpets. Everyone is truly grateful. So it's definitely the most rewarding thing. Seeing the impact that our work has on the human race is really quite indescribable. There's literally nothing like it. There's honestly nothing else in the world that I would rather do. So now let's go and talk a little bit about how and why Exolith Lab came to be. So as our presence has been growing in space over the last few decades, we're now facing the reality that space travel needs to become a little bit more sustainable. Our goal is to develop a conscious presence in space. So to do so, we need to utilize the resources available outside of Earth to develop an environment that will allow us to further our expansion into space. In our industry, we call this effort in situ resource utilization, or ISRU. As many of you may be aware, this is the sole goal of the Artemis program. So what are some of our specific goals? If we are able to produce certain materials on the moon, for example, then we don't have to launch them. If we are able to utilize the resources that are already in space, that cuts down on the quantity of launches that are required. So for example, if we want to be able to sustain long human exploration projects on the moon, we will have to be able to provide all the essentials on the moon for a long duration manned mission. So we want to improve our launch costs, decrease the amount of stuff we're sending into space, and use what we have available there to help us get comfortable there. A lot of our efforts that we're currently working on, we're currently focusing on a lot of 3D printing with regolith, volatile extraction for the use of fuel, developing things like solar cells with in-space materials to produce energy, and building regolith habitats. So why did we get started? There was a rising demand in our science community for testing materials that could provide us with more representable data. As we were spending a lot, or we were sending a lot of hardware into space, we want to make sure we can improve it as much as possible here on Earth, so that way we know it'll be successful when it leaves Earth. We also wanted to have a better understanding of how planetary bodies form and what those surfaces on those planets are actually like. We were also preparing for sample return missions, not just to the moons, but not to the moon, but asteroids as well. With humanity on its natural path to expansion, it is very important for us to start exploring more sustainable ways for us to settle the new frontier in space. Each of these goals require better testing materials so that we can increase our rate for success. So what's the problem with that? Why isn't that already available? Well, let's think about it a little bit. Real lunar regolith is not very abundant, and it's extremely hard to come by, and it's only available in very small quantities. So that pretty much rules it out as a testing material for most of our spaceflight hardware. Just try to imagine testing like a rover or rover wheels if you just have like one rock. There's not much you can do there. We didn't have many good asteroid simulants either. And to simulate asteroids, what we would do is we would use meteorites. But meteorites are also very limited and only available in small quantities. So we run into the same problem. The materials that we had available for analog testing were very limitedly available and not very well representative. So because of that, our data was less representative. And that leaves us unprepared. Getting into space is already hard enough. You saw the messes I showed you earlier. So we're not trying to lower our chances for success by anything else. I mean, unless you really love wasting taxpayer dollars, let's be honest. So why do we need high fidelity analogs and high fidelity testing materials? Anything we send into space has to be prepared for the space environment. And as we all know, space is very harsh. As we've been developing space exploration and ISRU hardware, we need to test it on Earth to make sure it's ready for the challenges it's going to face in the space environment. Some of the risks we want to address are damages to hardware, electronics, instrumentation, especially from the regolith dust. I mean, it definitely gets everywhere. And we can minimize these risks by testing with regolith simulants prior to launch. Seems easy. So many companies have definitely tried to be able to make regolith simulants available for abundant testing. This has been a hard task. Most of these companies have unfortunately failed. So Deep Space Industries was one of those companies that heroically took on the challenge, but then later decided that it would be a better challenge for somebody else. So in 2018, DSI's regolith simulant project was passed on to UCF, and that's where it became Exolith Lab. And of course, we had the generous support from the Florida Space Institute as well as NASA. So that helped us be on the path for success, but that definitely doesn't mean we didn't face challenges along the way. So what is it that we actually do at Exolith Lab? So we focus on making products that enable space exploration, science, and education. We make high-fidelity regolith simulants for different planetary bodies. We focus on the moon, Mars, and asteroids, I should say. So they accurately replicate the mineralogy, chemistry, and physical properties of the regolith. And in a minute, I'll tell you a little bit more about the secrets on how we make that happen. So due to the nature of what we do, we get to collaborate with basically anybody who's sending anything into space. Anyone who wants to be prepared for space, they have to come and work with us, which is great because we love that and they appreciate it too. We have really strong relationships with space agencies and research centers literally all over the world. Over here, I just have a few examples. Viper is a rover that's going to be using different spectrometers to identify specific materials on the lunar South Pole. The main goal is to investigate for water. It has a 1 meter long drill that's going to use to actually analyze the soil underneath the lunar surface. So this last year, we delivered over 20 tons of lunar regolith to NASA Ames to create a test bed for this rover. So we're confident that it's on the path for success. Space is still hard, but we're working through it together. So if you've heard of Phobos, one of Mars's moons, NASA and JAXA are collaborating to go to Phobos in 2024, where they're planning to do a sample return. So they're going to collect a sample and bring it back to Earth. We at Exolith Lab developed a custom simulant specifically for their mission to do their testing for their sample collector. With the UAE, we provided over half a ton of regolith. For regolith bin over there, they have a testing center. And more recently, we've partnered with the University of Adelaide in Australia. We literally just shipped over 10 tons of simulants, mostly lunar regolith simulant, lunar highlands to be specific, to our partners over there. They are developing a huge ISRU center. We're very excited to be partnering with them. So that picture on the bottom left, that's an entire shipping crate that's just full of our dirt that's getting shipped over there as we speak. So we also love to inspire young minds and encourage creativity. We work with several organizations to promote science outreach. We collaborate with the Daytona's Museum of Arts and Sciences for certain displays. We also work with NASA's Plant the Moon Challenge. We've worked with them for about a couple years now, and we've delivered over 2 tons of lunar and Martian simulant to enable student education. So the goal of this project is to answer the question, can we grow food sustainably in a lunar or Martian environment? And it never fails to blow our minds how these young students and young kids get so creative and come up with these just wild ideas that work. So it's really cool that we get to be a part of that. And I do want to say our science team and our students and a lot of our staff regularly participate in local grade school activities and events, doing talks for classrooms, and they love being involved in science fair projects and stuff like that. It's really great to be a part of the community in this unique way. So we definitely love our dirt. We have very many regolith simulants available. We also specialize in creating custom simulants for our customers who have specific needs. We partner them with our geology team and our science experts to create custom simulants for them depending on their requirements of their research. So let's talk about what the simulant preparation process actually looks like. So one of our main physical properties that we focus on replicating is particle size distribution. This is important because this is how we mimic the mechanical properties of simulant. We work hard to make sure our materials are processed appropriately to not only achieve the accurate size, but the shape as well. That's very important. After the materials are processed and the regolith simulants are prepared, we use laser diffraction and other methods to gauge the particle size. So that way we can accurately know the particle size sample. So what this actually looks like for us in real life on a day-to-day basis is basically we take big rocks and turn them into smaller rocks. There's a few steps in between. We used a lot of really heavy duty equipment. We also used a lot of blood, sweat, and tears from strong, brave people. A huge shout out to those. And we used a lot of mining equipment to break down the rocks. And then we use more mining equipment to break them down even further. We also use we sieve out our materials to make sure we have accurate and consistent grain sizes. So once our minerals are all prepared, we combine them in appropriate quantities to get our final products. This is done by kind of similarly to baking, where we follow a recipe. We have specific quantities that we mix together. And we use X-ray fluorescence and X-ray diffraction to confirm the purity and the composition of each of the constituents, as well as the final products. This way we can kind of make sure and gauge that we are accurately representing the lunar surface or the Martian surface, etc. So I know a lot of us love to look at the moon. We do have 2 main lunar simulants available. Our lunar highlands as well as our lunar mare simulants. Each one kind of serves as like a generic and accurate representation of either the highlands or mare region of the lunar surface. And just for visual representation, the mare areas are the darker parts of the moon that you see when you look up at the moon, and the highlands are the lighter regions. We also have some high fidelity dust simulants. So due to popular demand, we've had a lot of the science community is currently really interested in doing dust mitigation research to make sure that when we go up into space, we can properly survive in the very dusty environment. So we've modified some of our simulants to make them more adaptable to this research. What we did is we mechanically process our lunar highlands and lunar mare simulants to kind of better simulate the fine dust. So these basically, it's the same mineralogical composition, but the particle sizes are much finer. We also specialize in making asteroid simulants. We've made multiple varieties, but we mostly produce our CI asteroid simulant, which is based off the Orge meteorite. Our asteroid simulants have been used for both the Hayabusa and the OSIRIS-REx missions, if you're familiar. Those were both 2 sample return missions that have collected regolith samples from the asteroids that they touched. Of course, everybody loves Mars. We do have a few Mars simulants available. Our Mars Global Simulant is our generic Mars simulant that kind of represents the general Mars geology. And we base this recipe off of data that we received from the Curiosity rover. Some of the more primary uses of a simulant are things like plant growth studies, rover testing, water and volatile extraction, as well as human development and sustainability studies. We also offer ISRU-based variations of the simulant to help researchers practice things like 3D printing and building Martian regolith and building with Martian regolith and extracting water. So one of our very popular Martian simulants is, of course, our Jezero Delta Crater simulant. This is based off of the landing site where the Perseverance rover landed, and we did collaborate closely with scientists that were prepared to land there. So that was very exciting. So a little bit about our impact on the community and some of our growth. We've been grateful for the opportunity to make a huge global impact. We've delivered our regolith simulants to over 40 countries all around the world. This last year alone, we delivered over 20 tons of simulant, which is crazy. We've been working really hard to improve our processes to allow us to serve our community even better. So basically, we've seen over a 2,000% increase in delivered simulant in the last 2 years. So we have been working really hard to see this exponential growth, and it's definitely an exciting and rewarding place for us to be. So demand for our simulant just keeps increasing. We've been doing a really good job of making it very available to our customers. So they keep pushing us and asking for more, which is good. And we're definitely doing our best to provide the best types of products for our science community. So luckily, just a few months ago, we moved into our new facility. Here on the left, I have an image where you can see we're packed in like sardines at our old facility. And then on the right, you can see we quickly filled up all the space in our new facility, which is about 5 times as large. We're currently working on developing several regolith test beds all over the world. So this means providing several tons of regolith to many different places around the world so they could do their own in-house testing. And we are also planning on building one in our own facility as well. Dust is our biggest challenge, and we've been mindful and we've been learning a lot on how to work with it. But the things that we have been learning and the challenges that we're going through are very helpful because they are helping, and the data we're being able to collect and the experience we're getting is also helpful for lunar and Martian missions in the future. So, I mean, how did we see all the success? I promise it's not by accident. And as you can see, it wasn't always consistent. We've been seeing exponential growth over the years. We've been trying to focus on the right things. We're definitely grateful for our customers, collaborators, and partners. We definitely don't shy away from hard, tough labor. And this allows us to kind of give the opportunity for researchers to have confidence in their scientific test results. This is the core of why we do what we do. And at Exolith Lab, we definitely prioritize our team as well as our customers. And through this, we're able to stay united and keep moving forward to serve our community. It's definitely not always easy. So we stay focused on our mission. We create a sustainable space economy and make research possible for the entire science community. We stay optimistic in our journey and maintain a culture of collaboration. I do want to take this moment to give a special shout out to our science team. They definitely work really hard to make sure that our quality matches our reputation. And another big shout out to our operations team. These guys work harder than anyone I've ever known, and it is because of their hard work that success is possible for us. And that's all I have. Thank you, guys.
Thank you, Anna. That was fantastic. So I think we have some questions. I have one, but I'll go last. Looks like Mauricio has his hand up.
Sure.
Go ahead, Mauricio.
Hey, Anna, congratulations on this awesome achievement. It's so cool what you guys are doing on such a big scale.
Thank you.
One thing that I'm having a hard time understanding is
Sure.
I wasn't expecting so many different worlds that you guys are able to simulate, from asteroids to even the, I think, did I see that the moons of Mars are in there too?
Yeah, so Phobos is one of them, yes. So
where's
Go
that
ahead.
data come, where does the data come from? Like how, you know?
Yeah, so most of our data, depending on how intimate we are with that planetary body, of course, from the moon, we can replicate the lunar samples that we brought back from the moon. From Mars, we do have a few rovers there. We have a few satellites there. So there is a lot of data that we're collecting about that environment that helps us understand how we can replicate the geology of it. For some of the, and even, for example, for Phobos, we know a lot about Phobos. We've been observing it for a while. We have a lot of spectrometry data from it. And then we also have, so we do offer 2 different Phobos simulants based on the 2 different working theories of how or who Phobos is, right? So we have our Phobos Global Impact simulant, as well as our Phobos Captured Asteroid simulant. So this works on the Phobos Global Impact simulant, kind of bases the theory that Phobos was created by an asteroid that ran into Mars and got caught in Mars's orbit. So as you can imagine, we have a lot of asteroid simulant in there that also has some properties of Mars in there as well. And then for our Phobos Captured Asteroid simulant, it's actually just an asteroid simulant because in that theory, Phobos is just an asteroid that was captured in Mars's orbit. Does that kind of answer your question?
Yes, it does. Thank you so much.
Sure.
You're the next hand up. Eric Hoin.
Hey, Anna.
Hi.
Hey, amazing talk. I put my
Thank you.
question over in the chat room. Got a question. I think you answered part of it with Mauricio,
Okay.
where I was asking if there was a composition or a common material found in each of the simulants that would interconnect the simulants. I know they're from different worlds, different places in the solar system, but is there a common area that they share, common composition that they share?
Okay. Absolutely. Absolutely. So I can say there are a lot of base materials that are shared amongst a lot of the different planetary bodies. I am not the geologist, so I cannot go into detail about why, but I can say there's a lot of materials such as anorthosite, bronzite, and basalt. I don't know if those words mean anything to you, but those, for example, those are
Yes.
some very core components that are popular amongst all the planetary bodies that we simulate. And those are like the key components.
Nice. And then the such large shipments,
Mhm.
of course, the word ship is in there. So those are sent by ship.
Yes, 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 yes.
Okay. Fantastic. Just fantastic what you do in your
Thank
presentation.
you.
Thanks,
Thank you,
Al.
Eric. Mhm.
You're welcome.
So before I ask my question, Ramona, you didn't have your hand up, but I thought you were trying to ask a question earlier. Do you have a question for Anna? Or you might be having internet problems, so we'll just hold off on that. So, okay, so my question for Anna is space dirt, lunar simulant. Is this stuff, what are the health implications? How does the human body react to some of these materials, both chemically and just biomechanically from the abrasiveness of it?
Yeah, so this is a great question. So chemically, they're pretty inert. It's kind of a similar hazard to playing in a playground or like a sandbox or going to the beach. So what is hazardous is the fineness of the dust. And kind of like when you work in construction zones or work in a coal mine, the fine dust and the shape of the fine dust can get stuck in like your lungs over repeated exposure and create scar tissue that can be very damaging. So we do have PPE that we use to prevent those hazards from kind of affecting us. We use like very intense respirators and stuff like that. And we also implement a lot of dust mitigation techniques in our facility just to kind of minimize the risk and kind of minimize a lot of the dust. But like I did say, dust is our biggest battle. Does that kind of answer your question?
Yeah, so not only is it something you have to pay attention to making it, but in the future, a lunar base, controlling that dust and that environment. You know, here in Florida, we bring the sand in and it eats our carpets up, but on the moon, that problem is going to be even worse.
Oh, yeah.
Health implications as well.
Absolutely, absolutely. And we fully expect that.
Yeah. Okay, cool. Eric, do you have another question? I just want to make
real
sure.
quick. None of those materials, none of those simulants that you create, none of those are water soluble, right?
So there are certain components that can be water soluble. So for example, there are some materials in our Martian simulant that once exposed to water do dissolve in water. But that's some components. So that's, let's say, like 2%.
Okay, so nothing that would be nutritious for plant life, anything like that, right?
Oh, nutritious is not the word I would use. No.
Yeah, right. Just the opposite, right?
Yes,
Hazardous.
yes.
Hazardous, right? And then I know, I'm sorry to hog the questions, but the wasn't there a conjecture about, say we go to Mars, about using the Mars material to compact that to make cinder blocks or Legos or however in order to construct facilities, buildings, that sort of thing. So
Absolutely.
you wouldn't be hauling that over there. I remember from previous talk that was presented.
So that's definitely a huge topic. We work with a lot of companies, either private industry, also projects funded by different space agencies where they are working on those projects for sure.
Nice.
Yeah.
Nice. Fantastic.
Oh yeah. It's really great. It's honestly very rewarding. And even though what we have to do in the lab is extremely hard, it's rewarding to see the impact that and the opportunity that our products give and the kind of research it enables, because it is really cool. You know, our products are helping people figure out how we're going to build the lunar bases, the Martian bases. So it's quite wild. Yeah.
We will inevitably move out into the solar system. And this
Oh,
is,
absolutely.
this is the work that has to take place, you know, to enable
Right.
that. So that
Yeah.
is pretty cool. Pretty awesome.
Yeah. It's
Gotta
my
be
daily
nice to-
reality too.
And,
Yeah.
and she's a member of CFAS, and she even does outreach.
Isn't she
every now and then.
amazing?
So, hey,
This
I'm
has
a
gotta
big
be
fan
done
of
so I
CFAS.
yeah,
can retire on the moon. Got to get going on this.
Yes.
yep.
Yes.
I'm still hoping for my ticket to the moon one day.
But I'll be
All right,
back for
thank-
the CFAS holiday parties.
Yeah. Thank you again, Anna.
Thank you.
We hope to see more of you around. So, Derek, you are up next with member photos and sketches and such. Are you ready to take over?
Yes, I am. Yes.
All right.
I'm the Wizard
Take
of
it
Oz
away.
back here, controlling everything from behind the curtain, if you will. But anyways, Richard, if you want, I can go ahead and do both my programs, so that way I don't have to necessarily jump. You know, if that's okay. To do that.
Absolutely. I am flexible. We can do astrophotos and then your what's up tonight, and that way, yeah, just for continuity, so you can just get it
Perfect.
out.
All right. So
fine.
what we're going to do first is we are going to do the Astro Photo Showcase, which is technically actually not only astro photos, but it is sketches. And I want to make sure to see who is here. Looks like everybody that submitted a photo is on the list here. So if you see your photo, since we don't need to worry about the allowing to talk, if you see your photo, if you want to go ahead and unmute yourself, if you have access to talk via Zoom, we'd love to hear from you. We'd love to hear about what you have available or what you use to take the photo, sketch, whatever the case may be. We'd love to hear some more information about you. So I'm going to go ahead and start sharing my screen here. So we're going to start off with our first photo, technically it's a photo and a sketch. This is with our CFAS sketch extraordinaire, Bill Castro. So Bill, tell us a little bit about this work you've done here.
Yeah, I did it's got a new telescope. It's a 92 millimeter refractor, and the field of view on that thing is phenomenal. So I did a sketch on it. And then I remember when we were at the planetarium, Mauricio and I were playing around and taking pictures of M45 also with my cell phone. So for the heck of it, I just took a picture, a handheld cell phone picture. That's what you see in the middle there. And it came out pretty nice. That's the unenhanced image that you see. You kind of get an idea of the field of view. In the sketch, I did not draw all of the stars, because if I drew all the stars that I actually saw, it kind of takes away from the main star cluster there. But the photo, just the raw image, came out fine. And I was real happy with that. That's only 1 out of 5. And 2 of them came out pretty good. That's the one I thought came out a little best. I had a little bit of ghosting in there from the hand controller, but and I did a cleaned up version of that, and you can crop it and clean it up. It comes out really super. You know, everybody does their own image processing, so I'll leave that to your imagination. But yeah, a lot of opportunities with cell phones. I think Mauricio's been playing around with that a little more.
Absolutely. And my favorite thing that you have here on the sketch is that you have made it very clear to everybody that there are a lot of stars in M45. Very important note in that. So So thank you for that, Bill. That is the most important aspect of that write-up, that there are a lot of stars in M45. But yes, this is fantastic. This is actually a great way to kind of take a look at your work and reference it. You know, looking at this and remembering our star party, I forgot to add my Jupiter picture for the astrophoto. Shame on me, but that's all right. But it made me think about that night, of how good that night was for our mini star party. And I remember you doing that at this event. So pretty awesome stuff there, Bill. Thank you. And the next photo is submitted by Mauricio, our new outreach chief of staff. So Mauricio, what do we got here?
All right, so this is an event that I did with Leonard back in December at the Flaming Arrow Scout Camp. It was their powder horn event for scout leaders. And I saw that Andy Sova did a similar picture at one of our other events. And I was really inspired to try and do one myself. And I think it turned out okay. It'd be great to kind of do these more often, to, you know, put on social media and get people more excited to come out. I just love the imagery of people in line for a telescope and the stars above, you know. Not sure what you think about how the red cones turned out. I think I might turn them off next time, because I don't know if they're a little distracting, but I'll play around with that.
No, I actually think they look fantastic. In fact, they look so good, Mauricio. I just ordered a set of those cones for
Sweet.
outreach. So
Sweet.
you are an inspiration to us all for those cones. But actually, it does teach a very important lesson for safety in our events. Actually, a lot of people do ask me when we do outreaches and events, do you have safety precautions? This photo would show that in fact is something that we do consider when we do our outreaches, is safety. So actually, I think the cones provide that as a storytelling aspect of it.
Yeah, I'm
Hey,
glad you
Derek.
think so. Oh,
I was
Yes,
just gonna
Richard.
say, real quick, when you're done, could you post a link to where people can buy those cones? I think there's probably a few people in the club,
Yes.
me,
Yes.
who might order a few of those.
Yes, they
Great.
are fantastic, and I can't wait to use them on Saturday night. So, all right. So thank you, Mauricio, for that. You're going to be on a few more times, so don't go too far from your computer.
all right.
This one is from John Pinto, I believe. John Pinto, if you have been noticing, John Pinto has been very tenacious on observing the planet, especially in the early morning when most of us are sleeping, but John Pinto gets up very early to give us these amazing views. So John, tell us what we are seeing here.
So this was out my backyard just a couple nights ago. Mercury and the moon were setting, and I'm sure, Derek, you're going to be covering how Mercury and Saturn are going to be very close over the next couple of nights. So it just was a beautiful scene, and without that little circle, you probably wouldn't know that that's Mercury. So I just threw that in there. And that's just an old iPhone 6S, just using the Pro Camera app so that I can do a low light picture. But it works great.
Fantastic. Now, is that blue circle the rings, John? I'm joking.
Of course it is, Derek.
All right. So thank you, John. Yeah. See, again, a good example that you don't need fancy technology to take a picture of the sky. You can use whatever resource you have, including your smartphone. So consider that when you see something cool in the sky, take that phone out or whatever and capture it. Next photo goes back to Mauricio. I told you, Mauricio, you are going to be on here a few more times. So tell us about this image here.
All right, so this was taken at our, whatever the last event we did at the planetarium was. And so I had my cell phone adapter placed and I was helping people get this. This is my photo from my phone, but I was essentially helping everybody get the same type of photo. Now this one's been, enhanced in Photoshop. So you got the blacks really pushed and everything, but yeah, it's really it's exciting to see how excited people get when they get photos like this just with their cell phones. So kind of excited to see what else we can do with the public with this type of thing.
Agreed. In fact, actually, Marisa, you will be doing this at our event. We are also asking for anybody interested in coming out to our Observe the Moon night on Saturday. If you would have an additional scope, or if you would like to help with this, this is definitely something that people love to bring home with them, a digital souvenir, if you will, of what they saw. So this is a very great opportunity to connect our outreach audience and get a chance to get an amazing capture of the moon. All right, what do we got next here? We have, I think this is also you, Mauricio. So what do we got going on?
So I went down to South Florida not too long ago and got together with my cousin, who's also really into the space stuff, and he's kind of new to looking through telescopes and stuff. So we tried, this is a picture of Jupiter we captured with his cell phone, looking through the eyepiece of Celestron 8 SE. I was actually a little disappointed we couldn't get a better picture, because I've actually gotten surprisingly good photo of Jupiter just in one little snapshot on a much better conditions, and I think when it was in opposition. But yeah, it was a little turbulent this night, but it's still not too bad. I mean, he's got a photo of literally another world on his cell phone. That's kind of the excitement we're trying to, hoping that the planets is a little tough with outreach, because it requires a lot more tinkering. So it'll probably be a while before I do this with the public. The biggest challenge is you really need a third-party app that will let you drop the exposure down so that it's not just a white disk. It doesn't seem to be a problem with the moon because it's so big, but these planets are so tiny that I think I saw Sharif actually did Saturn one night, and it turned out like good, like you could see the silhouette, but it was essentially like a glowing like an eyeball, the Saturn shape. And so you really need that third party app to bring the exposure down like you do with this one. So we'll see if that's feasible for the public. I'm still kind of working on that.
Of course. John, you have looks like your hand raised.
So Derek, you mentioned digital souvenirs. Something to think about for the future is NFTs. We create some NFTs of these images.
I'm already ahead of you on that one, John. I'm already working on that so I could become a billionaire and build a ultimate observatory for everybody to use. Okay, no. Yes, that is definitely something to discuss. Maybe that could be a mini program in the future. All right. So yes, Mauricio, thank you so much. Yeah, of course, a lot of new smartphones are offering pro versions in their camera features. So hopefully we'll be able to offer doing more exposure changes as new phones start being used by more people. So, all right. I think this is also one of your photos, right?
Yes and no. It's actually one that Bill Castro sent me, and it's a cleaned up photo, fantastic photo of the double star cluster, which is probably my favorite star cluster. And he really just did a great job again with his cell phone looking through the eyepiece. And I think he's just hand holding these. Is that true, Bill? You're hand holding these?
Yeah, everything I've done.
Yeah, that's insane. That's insane.
This is toying with the new refractor, and then I'm using Nagler eyepieces for the really.
Yeah, he's got like it's huge, just like a huge. So it's much easier to just put it up to the eyepiece and snap that photo. But what's great, hey Bill, was this taken in pretty suburban skies, right?
This was taken in my backyard, Bortle 8000 sky, I think. And,
yeah, so
and handheld with the moon at almost the moon was washing out a lot of stars.
So I'm just blown away by I never thought that we could do deep sky objects with the cell phone. So the potential of doing pictures like this with the public, I think that would just get them extremely excited, because this is just a phenomenal picture of the double star.
But the imagers in the club, the original raw image of this had some internal ghosting reflections and all that in the corner. So again, you remember that other picture in the first slide, you can clean that up to look just as good as this.
Yeah, your raw image is going to have that classic, you know, the window, the little circle, and you know, it's not
Yeah.
going to be super. I'm assuming most people probably won't clean up their photos, but I think they'll be excited nonetheless just to have pictures of stars and you know.
Well,
Absolutely.
the cleanup was you could do it in just Microsoft Photos. You can adjust the darkness and crop
Yeah.
it and do it in there.
Yeah, Photoshop has a really good Express app that you can use on the phone, and yeah, it does a great job with some quick editing.
All right. So yeah, well, this could be a workshop that we could put together in the future. This is
Yeah.
definitely inspiring some people. So again, thank you, Mauricio. And I think this is also another one that you can kind of see that window.
Yeah, there you
down
can.
there.
Yeah, this one hasn't been touched up at all. This is just the raw image. This is the Dragonfly cluster, also taken through my cousin's cell phone, looking through the Celestron 8SE. And I always find this star cluster to be very charismatic. I think it looks like ET with his arms up. But yeah, just this is not like, this is not a particularly prominent, super big or bright star cluster, so it's just awesome that it can come out like this with just a snapshot. I do want to point out that the 8SE has basic tracking like you would expect from the Go-2s. I'm not quite sure what would be possible if from like a Dobsonian that is just manually positioned. I imagine you'd get some motion blur with even just like a 1 second exposure, but we'd have to try it out with some other club members to see what
Yeah,
you
well,
can
that could be
capture that
something
way.
that we could experiment at the Winter Star Party on
Yeah.
the 22nd. So
Yeah, for sure.
all right, and then I think this is your final.
Yeah, I think this is the last one.
stuff.
This one I was just really surprised. Again, this one's through my cousin's cell phone, Orion Nebula. I did some touching up for him in Photoshop Express on my phone, and then sent it back to him just to show him, hey, like these, check out these colors. Like, but in the raw image, like you could already see reds and blues popping out from the nebula, and it was. I doubt it was more than a 2 second exposure from his cell phone. So I was just really blown away that we could get like such a nice, quick and fun image. And this is the kind of thing that I think would really blow people away. And I plan to, on the 22nd, when we have our star party, I'd like to put the telescope on Orion Nebula and throw on a couple cell phones in there and see if we can maybe get some pictures like this. So
Fun fact, back in 2005, me and Mike McConville, who used to be a member of CFAS and worked with me at the planetarium, we imaged a image using a 12-inch LX200 with a old SBig CCD camera, and this is what we got with it back in 2005. We thought it was the coolest picture we've ever taken in our lives. And that was in 2005. So imagine what smartphones will be able to accomplish in another 10 to 15 years, or even more, or even less than that time, 5 years, especially with the advent of computational live stacking technology that's being worked on right now. So pretty cool stuff. So thank you, Mauricio, for that's something definitely I'm passionate about doing as well. So I'd love to work with you on bringing that more to the public. So lots of awesome stuff to get people to take some pictures of outer space that they can share with their fellow family and friends. So thank you so much.
Sure thing.
All
I'm
right,
excited.
now we had to jump from that to that. But this is Frank Kane's. This is what happens when you have a lot of time and a lot of resources to do a really cool picture like this. So Frank, give it away. Take it away.
Yeah. This is the Orion Nebula, obviously, and its friend, the Running Man Nebula above it, and definitely not a few seconds through the cell phone. This is actually an all-night-long endeavor here, about 8 hours of total time, taken through my Skywatcher 190mm telescope and a ZWO ASI 2600mm Pro camera on a Paramount MIT mount. And yeah, this is just straight up RGB colors through color filters, combination of 10-second and 60-second exposures. But yeah, I mean, kind of going back to the cell phone idea there, I actually wish I took shorter exposures than that even, because it's a little bit blown out even at 10 seconds. So going down to 1 or 2 seconds might have been a smarter choice there, but still happy with how it came out. Our friend, the Orion Nebula.
So another 5 years from now, our smartphones will be able to capture this, right now.
Yeah, I wouldn't be surprised. This is a pretty,
Yeah.
pretty bright object. So yeah, it could happen.
It could happen. Bill, you have your hand raised?
Yeah, Frank, can you highlight the Running Man part? I never really see the Running Man part.
I don't have a pointer, but I think Derek's pointing it out there.
So that's his legs.
So it's seen multiple ways. So some people see that his leg, there's his foot, there's his head, and he's kind of running like this. Some people see him running with his legs like that. It's all, all on the person there. So, but the way I see it is I see there's his head, there are his legs running, and he's kind of like in a stance, like he's running like that. So.
Yeah, that's what I see too. And it was a stretch for me as well to get there. So don't feel bad.
All right.
Thanks.
Frank, this is another one of we're going to stay with Orion tonight.
Yep. In the other corner of Orion by its belt and the star Alnitak, this is what you'll find: the Horsehead Nebula and the Flame Nebula, and another little reflection nebula there between them, whose name I forget, NGC something or other. But this one is actually about 43 hours of exposure time taken over multiple nights. And that's just to get as much detail as we can in those clouds of gas that the Horsehead is kind of oozing out of there, and all the surrounding tendrils there. This is actually a combination of narrowband data and RGB data blended together to kind of get the best of both worlds. For all that detail and the hydrogen there around the Horsehead and the Flame, you really want to get that hydrogen alpha filter data in there. But for the reflection nebula, that blue thing underneath it, that only shows up in color data, RGB data. So the challenge of processing this is blending them together in a way that looks somewhat natural.
And then that little blue nebula there is actually very challenging to blend. So you did a great job with blending that. A lot of people, when I see their photos, it's blown out quite a bit. So that was a nice depth there that you did there, Frank.
Thank you.
So, and there we go. Another one, Frank.
Yep, the Rosette Nebula, shot entirely in narrowband. This is also an all-nighter, about 8 or 10 hours, if I remember right. Processed in kind of a modified Hubble palette, we call it. Usually we match sulfur emissions to red and hydrogen to green and oxygen to blue. But if you mix them up a little bit, it looks a little bit prettier. And that's what's going on here. So not strictly Hubble palette, but a little variation that looks a little bit more pleasing to the eye. This is the home of a star cluster in the middle of it, obviously. And kind of a new thing with this new camera I have is that it has a bigger chip on it. So this is the first time I've actually been able to capture most of the Rosette Nebula in one frame. So I was pretty happy about that.
Yeah, one of the things I do appreciate about your photos, Frank, is that you tend to go with a little bit different style of photo. Usually I'm scrolling through lots of different astrophotos over the course of the day, and it's always usually the same thing. But every time I see your stuff, it stops me because I'm like, wow, that's actually a different take on that object. So I do commend you on being a little bit thinking outside the box when it comes to these photos. So keep it at it, I should say. So, and I think this is the final. Oh no. I think the galaxy photo you submitted fell into the supermassive black hole of the universe. So we'll save that for next month. So, but that's what we have here.
Hey Frank, really quick. I just wanted to say, it is what Derek said. It's really interesting, the idea of taking a photo that literally physically you can only get the same angle from everywhere in the world, right? Everyone takes the same object. So it's really cool how your compositions and colors and everything are very unique.
Yeah, applying like basic photography techniques, rule of thirds, stuff like that, and thinking about color palettes, that's really as much of it as anything else. So thank you.
Yeah, I actually attended a talk by Tony Hallis on that at a conference one time. It's how to make your pictures pretty and tell a story. And that's what I always tell myself. Anytime I take a photo, no matter what it is, What's the story I'm conveying with it? So that if you are interested, again, you could do anything, smartphone, $40,000 pieces of equipment, doesn't matter. If you have a story you want to convey, take it. And we'd love to see those photos at the next CFAS Astro Showcase. Now, what we're going to do is, speaking of which, how can you look for these objects? Well, we're going to go ahead and explore the nighttime sky right here using our stellarium. Now, hopefully next month, keeping our fingers crossed, we'll be able to actually bring you back into the planetarium and show you the view of the night sky through there. But until then, this is all we have for right now. And it's a good substitute. So what we're going to do is we're going to go ahead and journey on over to the western sky. Now, I know that John Pinto did mention about some interesting objects. So, of course, we're looking at about 8 o'clock right now. So let's go back in time a little bit to about sunset, which is around 6 o'clock now. So around sunset, what you're going to notice on the western horizon, if you have a nice, clear western horizon, if you have a chance to take a ride over to the Gulf of Mexico, this would probably be your best bet. If I've been able to actually make these observations over there. But what you'll notice here is you got a nice western, southwestern horizon. You're going to see a couple of planets in the sky here. We have Mercury, as John Pinto showed in his photo. Just above that is the planet Saturn, and above that is Jupiter. Jupiter's going to stay up for quite a while. So that will be the main object that we want to observe for a little while here. But what I'm going to do is I'm going to kind of go into the next couple of days. So we're going to go to the 13th, 14th, so on. And you'll see that over the course of the next couple of days, Saturn and Mercury are going to be fairly close to one another. So if you have actually a pretty decent scale, you might be able to capture both objects in the same field of view, maybe even get the shape of Saturn in there. But this would be a really nice, especially with a wide field telescope, might be able to take a look at both of those, or a pair of binoculars, I should say, that way as well. So we have a question on what application is this? This is Stellarium. This is a free software that you can download at your home. Stellarium, it's actually accessible not only on desktop, but also mobile applications like smartphones, iPads, things like that. It's a great program. So anyway, so this is, so we got Mercury and Saturn very close to each other over the next couple of days. They'll start getting lower and lower and lower in the sky. So definitely get a chance to take a look at that while you can. So there you are. So those are our 3 planets. We do technically also have Neptune and Uranus in the sky if you want to take a look at those. We're going to go ahead and set the sky. We're going to go back to 8 o'clock. That's kind of where I like to start off my presentation here. And what we're going to do is we're going to make our way over to the eastern sky. I want to focus most of our talk tonight on the eastern sky and into the zenith, because this is our main winter constellations of the sky. And the first one we're going to look at, of course, is the most famous of all those constellations that I generally, most people know where to find Orion in the sky. Orion is probably one of the most famous and most recognizable constellations in the sky. And of course, we can recognize the 3 stars of Orion's belt: Alnitak, Omnilam, and Mintaka. And of course, just like what Frank mentioned, right next to Alnitak is the Flame and Horsehead Nebula, right over here in this area, just next to Alnitak. And of course, just below the belt of Orion, you'll see a vertical group of stars that make up what supposedly we call his sword. And that is essentially where we find the Orion Nebula. Right here, you can see the Orion Nebula with the Running Man. You can also see the Horsehead and Flame right here. And all throughout Orion, there's lots of different objects in the sky. For example, if you continue onward, you got the Horsehead and the Flame Nebula near Alnitak. If you continue on heading towards the star Betelgeuse, you will see another group, this is M78. This is a really, really nice nebula as well that you can photograph. This is actually a very great object to look at in the sky as well and photograph. With a telescope, you should be able to catch a little bit of those what we call dark nebulae, which are those dark dust lanes. Now, this is a astrophotography only target, but right next to the bright blue star Rigel is a very large cloud of dust, or it's a reflection nebulae called the Witch Head Nebula. And you can see right here, you have the nose, here's the mouth, the big chin of, and so this is the head of our witch. So this is the Witch Head Nebula. So lots of various targets to photograph inside Orion in the sky. So this is a great place to look at. Now, Orion, from there is also our hub. Think of like an airport, a hub, your central location. If you're able to identify Orion in the sky, you can then find most of these constellations I'm going to bring about tonight as well. So if we take Orion's belt and we go up from Orion's belt, eventually we'll make our way over to, and I'm going to go ahead and turn off the atmosphere because unfortunately the moon's up too, which by the way, yes, the moon is up. And if you are having a hard time finding the moon in the sky, well, we might want to steer you back down to get you acquainted with the sky a little bit more. But right over here is the star Aldebaran. Actually, the moon is very close to the Hyades star cluster, which makes this V shape of the bull's head right here. And so this is, again, a very nice object to photograph tonight. Maybe I might do that after the program tonight. Maybe we can get some really cool images. And this is Taurus the bull right here. This is his head, the bright star Aldebaran. Over here, we have two stars that make the horns of our bull. And over in this area right here of Taurus, in fact, actually, let me go ahead and find it right over here next to this. Whoa, went too far. Right over here next to this star in the kind of the star closest to Orion in the horns of the bull, you can find what's called the Crab Nebula, which is a supernova remnant. So this star has said to explode, and the light of this supernova event occurred and was visible around 1066 AD, and people from all around the world have documented this event. And of course, finally, we now see the aftermath of this supernova event itself. So a great object to take a look at. I don't really see too much of a crab here, but some early observers noticed that there's right here we have one claw, we have another claw, and then this would be kind of its body. That's the best I can get with the crab there. So trying hard to make the sense out of all this. So, all right. Okay, so again, we have the okay, everything's a little, I need to just do a couple of changes here. Let me bring this down a little bit. There we go. Perfect. Okay, just want to make sure that our scale was good. All right. So we have Taurus here. We have the Crab Nebula. And just above Taurus's head, the Hyades, we can see another cluster of stars here, which is the Pleiades. And we noticed with Bill Castro's view earlier, this, of course, is the Pleiades star cluster. Beautiful object to look at. Very easy to see under light polluted skies and even a pair of binoculars. You don't need a very large telescope to observe the Pleiades. So this is a great introductory object to look at in the sky. Now, one of the stars of Taurus's Alnath right here, which is the star that makes up the right side of Taurus's horns, actually belongs to another constellation right here. We have 1, 2, 3, 4, 5 bright stars that make essentially a pentagon shape. And this constellation is Auriga the Charioteer, with the brightest star being Capella. Think of a cappella if you're a singer, but without the A, Capella. And throughout Auriga, there are several really nice star clusters all throughout here. There's M36, 38, and 37, all throughout this area. There's tons of, there's the Flaming Star. There's tons of great deep space objects that you can also observe in Auriga. So there's lots and lots of great emission nebulas. There's a lot of star clusters, lots of things that you can photograph in this part of the sky as well. Now, so we looked at Orion, we looked at Taurus, we looked at Auriga. Just below Auriga, kind of over to the left of Orion, we'll see two stars, two stars right here. This is Castor and Pollux that make the head of the Gemini twins. So here we have the Gemini twins here. Again, lots of interesting objects. There's M35. There's several other there's the Jellyfish Nebula. Lots of other objects that are found throughout Gemini as well. And let me go ahead and put up some constellation lines just to kind of make it a little bit easier for us to pick out those constellations. So we have the head of Castor coming down. We have a couple, one like foot, or it's not foot, but arm. Here we have the foot and leg and kind of the stick figure shape of one of the twins. And we also have the other shape. And poor Pollux, he has T-Rex arms, really small arms, very long legs right there. Now, just below Orion, now instead of taking Orion's belt to the north, going up to Taurus, we're going to take Orion's belt to the south, and we're going to find the brightest star in the night sky. That's Sirius right here. And Sirius belongs to the constellation of Canis Major, the big dog. So here we have our dog's head right here. Here we have the body of the dog. We have a couple of legs and the tail. And there's some really interesting objects to observe in this area too. There's M41. There's Thor's helmet, which is a large star we call a Wolf-Rayet star, which is kind of a very unstable star. Lots of different things to look at in this area as well. But what we're going to do is we're going to look for a thing in the sky called the winter triangle. And the other star that we're going to use is this star to the left of Sirius called Procyon. And Procyon is basically this little tiny area in the sky that essentially looks like a hot dog. That's Canis Minor, the little dog. So Procyon is the main star in Canis Minor. It's been a long day today. Canis Minor, the little dog. And what we're going to do is we're going to take Betelgeuse up here. We're going to take Sirius, and we're going to take Procyon, and we're going to combine all three to form what we call the winter triangle. This is an asterism, which is actually an unofficial pattern of stars in the sky, and that will help us figure out and connect those areas of the sky that we want to look at. Now, inside this triangle is another very faint constellation in the sky called Monoceros. And in that area, we find the Milky Way. All right, so the Milky Way runs through this area of the sky, what we call the Orion arm of the Milky Way. This is actually the part of the Milky Way that we are generally part of. You'll find things like the Rosette Nebula, which is right here, which of course Frank took a very beautiful picture of. And off to the right of that, we have a couple of other objects. We have the Christmas tree cluster with the Cone Nebula here and the Fox Fir Nebula. This whole area is also a great place to photograph objects in the sky. Now, I don't want to inundate all of you with lots of things, so I wanted to focus, this is a mini program, I just wanted to focus on this part of the sky. This is what I call the main attraction for this time of the year, the winter constellations: Orion, Taurus, Auriga, Gemini, Canis Major, and Canis Minor, and Monoceros. So there you have it. There is your tour of the night sky. Be sure to keep looking up, and thank you so much for your time.
Thank you, Derek, for your time as well. And next up is me. I'm going to spend a minute on the moon. As you know, I never spend more than 1 minute on the moon, but I am going to break that rule today and spend a couple of minutes on the moon, if you will permit me. Since we have a Observe the Moon event coming up, I thought I would talk about some lunar observing programs that you can participate. Why? Why on earth would you want to participate in a lunar observing certificate program? Well, personal glory, of course. Also, it helps, it's great to set goals to progress in your hobby. It's a great structured learning opportunity. When you learn a new topic, having a a framework to go through always helps with that. You can do it by yourself, or you can do it with friends. One of them I'm going to talk about, you're not supposed to use friends, you're supposed to do it by yourself. I actually found quite a few of these programs. You can do it at your own pace. Nobody's watching over your shoulder. Nobody's going to call you a loser because you were tired, or it took you 6 months or 6 years to finish your certificate. And of course, as always, it advances your skills and knowledge. You did join the astronomy club. You must be interested in astronomy. You probably are interested in learning. So this is a great way to do that. Why the moon, of all things? Well, it's up whenever the moon is up, which is quite often, as it turns out, even in the daytime. Light pollution, who cares? We don't care about no light pollution. You can do it from downtown in the city, in the parking lot at Starbucks with all the lights blaring. It always amuses me when I do Coffee and Cosmos at Starbucks and the lights are up and we're looking at the moon, and there's always somebody who's programmed to say, can't we turn these lights off? We don't care. It's the moon. The moon is pretty bright. That street light is not going to affect it. So you have no excuse for not looking at the moon from your driveway, no matter where you live, unless, of course, it's on the bottom floor of a parking garage. Live in the city, so what? If it's a little hazy, big deal. You actually don't need super great transparency to see the moon. You can actually see the moon pretty well through thin cloud cover. Don't have a telescope? You don't need a telescope to see the moon. You can see it naked eye. There are also programs where you can just use a pair of binoculars, or of course you can use a telescope. So our first one, the Astronomical League, of which you are a member. If you're a member of CFAS, you are also a bona fide member of the Astronomical League. They have a great program called the Lunar Observing Certificate 1, which is sort of a foreshadowing there. There are naked eye components to identifying features and things that go on the moon. You can also do optical. There are also, of course, optically oriented activities, both with the telescope and with binoculars. And there is an option, and this is actually new since I think the last time I talked about this a few years back. You can do an imaging program on the moon and earn this certificate. There is also Lunar Observing 2. Who thought? Observing program. You have to observe. You have to acquire the Lunar Observing 1 certificate first. This can be done visually or remote. You can't do the first one remote, but you can use a remote telescope to look at things. And there's no sketches or images. It's all completely visual. This is a bit more of an in-depth study of the features, so it's very, very educational course. The last one for the Astronomical League is the Lunar Evolution Program. Same targets that you're going to observe multiple times, but under different conditions based on lighting and libration. That's the tilting of the moon, or the apparent tilting of the moon, I should say, that we see over the course month to month as it orbits. And of course, you need to either sketch or image, one or the other. This would be a great thing for our wonderful sketcher, Bill Castro, but also our imagers can do photography for this. By the way, the URLs are at the bottom. You can rewind the YouTube video to catch those. Also, Google Works, Astronomical League, lunar programs will find all of these for you. And you are a member of the Astronomical League. And if you send in the requirements to me or to the Astronomical League, because I'm the Astronomical League coordinator, by the way, we'll get you a certificate and a pen to show that you have gone through the Lunar Observing Program. The Astronomical Society of Canada, or RASC, also has two really great lunar observing programs. The first is called Explore the Moon. This is an introductory level lunar observing program. It's ideal for beginners. They even say in the text it's for people who are just learning how to use a telescope or a pair of binoculars. In fact, there is a binocular sub-program where you only have to identify 40 features using binoculars only. And this is the program where they want you to do it on your own. They don't want somebody, finding all the features for you or a group activity. So this is more of an individual effort, but it is very beginner. They even give you a photo album that you can download that shows you where on the moon the features are and shows you a photo of what the moon, of what the feature looks like. So you don't have to find things in a lunar chart yourself to do it. Now, for the more in-depth, the Royal Astronomical Society of Canada also has the Isabel Williamson Lunar Observing Program. This is nothing short than a course on lunar observing. You're going to learn about lunar geology and history, lunar features, about libration and how it works. There's a lot more reading and study with this program, but the checklist is actually a lot easier. You just go through and do the checklist. And I pressed the button too long. There's not 1,000 items for this lunar observing program, but there is also a bonus 1,000 item, Lunar 1,000. That's not a checklist. A lot of you have heard of the Lunar 100, which is a Charles Woods Sky and Telescope list, but there are 1,000 different features on the moon that you can observe. And all of these materials are free to download. And actually, this is true for all of these programs that I'm talking about tonight. Even if you don't turn it in for the observing certificate, you can download all of these features for free on the internet and just go through it just for the sake of going through it. The last one that I'm going to talk about is from the now defunct American Lunar Society, or the Moon Society. Their website is archived at legacy.moonsociety.org. And they have a lunar study and observing certificate. They've got a great little booklet that you need to read, and you take an open book test on it called the Lunar Geological Processes on the Moon. And they have about 90 features to study and observe. Now, this is all free, but it is strictly a personal study project because they don't exist anymore. Back in the day, I actually remember it used to cost $50 to get this certificate, and CFAS would actually sponsor that. If you wanted to sign up for this, we would pay the $50 and you could go through the program and get the certificate. And I remember Ray Jones, if anybody remembers Admiral Jones, he earned this certificate as a matter of fact. Finally, more information about the moon. I've got 3 tiers for you. There are tons, there are thousands, there are hundreds. You could do an entire program about things to find on the moon. If I don't mention your favorite book or resource, I'm very sorry. Please give a mini program in the future. You can talk all about it. But I'm going to give you 3 here. 50 Things to See on the Moon. It's $17 paperback. It's also available on Kindle. Very approachable. Children can flip through this and find things. It's really great. If you want to get a little more serious and invest some more, I really am a fan of the 21st Century Atlas of the Moon by Charles Wood. $34, spiral bound, and it's due safe for outdoor use. The pages are whatever the pages are made out of, so that it doesn't. You can use it outdoors and it can get wet. Now, for these extreme lunar maniacs, there is a 3-volume set called the Lunar Cognita, which is my very favorite reference on the moon. Everything you could possibly want to know about the moon, lunar history, the moon and culture and religion and society, all the way back to cave paintings on the wall and lunar science, and then lunar features. And it goes into extraordinary detail about it. Also, one of the great things about it is the named features on the moon. It actually tells you a lot about who it was named for. So if you go like Tycho, well, everybody knows who Tycho. There's a crater called Vogel. And if you want to know who Vogel was and why he got a crater named after him, Lunar Cognita is a reference that will let you know. And of course, finally, don't forget our free friend, www.google.com. If you Google lunar maps or lunar atlas, you'll get all sorts of free links as well as pay. There's even a virtual moon atlas available for Windows that's free that you can download and play with. And that's all I have, but I see John Pinto has a little hand up. John, do you have a question for me?
Yes, for the RASC certificates, to actually get the certificate, you have to join RASC?
Yes, you do. You do have to join the Royal Astronomical Society if you want one of the certificates. You can go through the program. Of course, the materials are all free. I actually am a member of RASC and plan to get the certificates. But if you want the actual certificates, you have to be a member. The same thing goes for the Astronomical League. You have to be a member to get those certificates. But all of you with your paid CFAS memberships are automatically members of the Astronomical League. So you are already in the program for that. So that's my couple of minutes on the moon tonight. If nobody else has any questions about that, I wish I could see you guys this Saturday for our moon night. I am very excited about that. We'll definitely have to do that again. Next up is on my list, I've got Elaine, who's going to take us from the moon to the sun. Actually, the moon meets the sun, and talk about her experience in the Antarctic. I didn't go as well as planned, but I'm still jealous. That was a great trip. Elaine, you want to take it away?
Tip this a little bit. Okay, back in November, I talked about an upcoming trip that I had. And so I can get this, the right one to come up. As you may recall, it was called, the previous presentation was a minute and 54 seconds without the sun. And I followed Eric's presentation about the sun. And the minute and 54 seconds referred to the total solar eclipse of December 4th, 2021. And this is the area where that was visible. You can see the Antarctic Peninsula reaching out there in the middle of that half circle, and the—
We do not have your screen, Elaine.
Yeah.
All I see is you.
Oh, okay. Wait a minute. What do I need to do?
And your parka. Share screen, the button down at the bottom.
Let me go
Should
back.
be a button down at the bottom.
Share screen. Okay.
And it should pop up and you have to say, yes, you want to share the screen
Wait a minute.
somewhere.
Share screen. One participant share at a time, multiple participants, advanced options. That's what it's giving me.
One at a time. Try that.
That's what's checked.
Oh, okay. So if you click the share screen button,
The green one.
Oh.
The green one.
yeah, it should pop up and
Ah,
oh, I see some stuff on, I see computer screen.
okay, that's
Looks like
not
your email.
right.
Do you have two
Mhm.
screens?
Now I don't know where my PowerPoint went. I think I can find
Looks like
quickly.
it may have closed.
Yeah, that's what I'm thinking. Come on.
It's a nice desk.
Okay, there it is.
PowerPoint.
Okay,
All right.
now I go to, I want to go to slideshow, which is underneath the banner at the top.
Somewhere.
Oh, there, I can do it that way.
I use
Okay.
Keynote. There we go. Perfect.
Is that right?
That's right. I see it, and I see you very small with your parka on. Is it cold where you are? Or are you wearing
Oh,
that in
it's,
honor
it's,
of your?
it's freezing.
Okay.
It's about 60 degrees.
Wow.
All right, backing up.
Take it
In
away.
November, I talked about a minute and 54 seconds without the sun. That was after Eric's presentation on the sun. And I was referring to the total solar eclipse of December 4th, 2021. This is the path of the eclipse. And here in Antarctica, you can see the Antarctic Peninsula reaching up in the middle here. And this was the only part of the Earth where you could see this eclipse. And there's the point of greatest duration in the Weddell Sea, which is virtually always full of ice. So I was on a cruise ship called Le Commandant Charcot, which is the only purpose-built cruise ship icebreaker. There are icebreakers that take passengers and function as cruise ships, but this was built as a cruise ship icebreaker. And I had a very nice cabin. This was not like any working ship that had been converted to passengers. This was first class. I did try on some of the safety equipment. One size fits all, and not flattering to anyone. But if I was going to end up in the Arctic Ocean, I wanted to be familiar with that. My first iceberg, and they did give us these lovely jackets to help keep us warm. Now, this is a map of the route that the ship took, and we came out of Punta Arenas, Chile, up here in the, let's see if I can go back, up here in the upper left corner, and we came way out here to the right-hand side in an attempt to see the eclipse. And it took quite a while to get there. And when we were in position, there was a great deal of anticipation. You see, most of the passengers are wearing their lovely parkas that the cruise provided. The people in the yellowish green, those are the expedition team leaders. They're part of the crew, and they talk about the various things we're going to see. And then the people in the blue parkas are crew. Now, some people are wearing their own jackets. And here we are gathering out, getting ready for the eclipse. And that was it. It got a little dark. And then it got light again. And of course, everybody left. It was rather disappointing. We could tell there was a difference. As I said, it did get quite dark, but could not see any of the eclipse itself. But they made a sincere effort. In the lower right-hand corner, you can see the maneuvering that the ship did, trying to get up in the path of the eclipse and somewhere with clear skies. And it just didn't work out. I'm sure a number of you have tried to see eclipses and other such things and had similar luck. Let me go back for a moment. Now, after the eclipse, then we headed west down toward where it says orcas. Where it says orcas is where we saw orcas. But it took about 2 days to do that. And during those 2 days, there's a number of interesting things on here. In the lower right corner, it shows that on December 4th, the sunrise was at 2:43 in the morning. But if you look a little further up, it's showing the winds. And we had some pretty good winds for a period of time during the travel toward the Antarctic Peninsula. I realize now I unfortunately cut off the beginning of our position. I believe the first figure should be either 60 or 61, but we had a bit of a rough time moving. Fortunately, the ship pitched and didn't roll. It had very good stabilizers. And then we got down here to the Antarctic Peninsula, and this shows our route during our time there. As I said, it's an icebreaker, so we were able to go places that other cruise ships can't. Other cruise ships would be here on the west side of the peninsula where there's a lot less ice. Our course zigzagged back and forth because we were trying to find good ice where we could get off the ship and walk on the ice and things of that nature. And see little critters like this. Now, I did test out that half circle swimming pool on the stern of the ship. You can see in the background here, there are ice-covered mountains, but the pool was nice and warm. And of course, there's a crew member waiting with a big warm towel when you get out. Now, other than when we had the eclipse, we had gorgeous weather. Some clouds, but just gorgeous weather. So you win some, you lose some. One of the days we did find good ice, and the ship went into the ice, and then they were able to put the gangplank down, as you can see, and we were able to walk off the ship onto the ice. John Pinto has a question.
How are the night skies down there?
There really wasn't. It didn't get dark. This was December in Antarctica. It's summer, and we were
Midnight sun.
Yes, we were about 60 degrees, so there was no night sky. Of course, there would have been no ambient light, but we had the sun. So on this particular day, we walked off the ship and onto the ice. And when we came back to the ship, they had afternoon tea time set up on the ice at the bottom of the ramp. There was no tea, but there was hot chocolate with various things you could add to it, like amaretto and Baileys, but they did have the little tea cakes, and it was all very lovely. This is what the ice looks like after the ship goes into it. If you look down the middle here, you can see this is all chopped up, but this has drifted back in. And then close to the stern of the ship, it's still clear, but gradually all the ice will drift back in to that spot. Hiking on the ice, it was summer in Antarctica, and I found a lot of it quite warm. I am wearing 2 shirts and a pair of tights. The mandatory boots, no gloves, and it was summertime, and it was a little bit sloppy some places. In this shot, I have my jacket on because we're Zodiac touring, and you get a little bit of wind chill as the Zodiac moves around, but look at that sky. Wouldn't have it on the 5th. This shows it was quite warm. There was glacier on top of this mountainside melting. And to give you some perspective on that mountainside, it's this piece, and there's a Zodiac right down in this area, little black speck. This day, the ship is nosed into the ice, but the ice was not firm enough to walk off of the ship. Once again, beautiful, clear skies. We did have some interesting clouds. I don't know the correct name for this one. It's kind of like a lenticular, but it's got a lot of other things going on. We stopped on 2 islands, and we did 2 hikes on ice in different places. This was one of the islands, and I was with a group that hiked to the top, and it was interesting that Anna did the presentation on regolith, because this was very much like our impressions of Mars, very dry. And we climbed way up to the top, and it really looked like a Martian landscape. But once again, very warm, and particularly hiking, you get a little hotter. Our ship had a little, go ahead, Mauricio.
So Elaine, I've never in my life walked on ice that wasn't like a skating rink. What is that experience like in the Arctic? Is it unsettling, or do you hear noises, or what, what's?
Well, they were very careful where they put us ashore. The ship has a lot of sonar and ice measuring devices, and when they pick a spot, they send the expedition team ashore first, and the expedition team tests the ice, measures the ice, walks around. If they find most of the ice is good, but there's a thin spot, they'll mark it off with barriers so that we don't go that way. But it was, a lot of it was melting, so it was sloppy. And we did climb up on some places that icebergs had gotten wedged into the sea ice. It was interesting. No, it didn't make noises, but there were some places that looked pretty translucent that you kind of didn't want to walk on.
Wow, I bet that's pretty though.
It was otherworldly. It was neat. This ship has an additional feature because it goes into the ice. It has its own helicopter. Now, the pictures I was showing of the people assembling for the Eclipse, there's no helicopter. That's because it has a hangar. The helicopter, they use it for scouting the ice and possible places for us to land. It is also for some science, and it is also for emergency rescues, evacuations, or things of that nature. Anytime anyone was off the ship, the helicopter was on the deck. So at this point, it is getting ready for us to head back to South America. So they've taken the rotors off, and they put the little wheels underneath, and they've opened this big hatch, and the elevator has come up, and they roll the helicopter onto the elevator and it disappears and the door closes. Because coming back, it was a little rough. But once again, we had gorgeous skies. All right, now I want to get rid of the want to get rid of the PowerPoint, but just go back to me. So stop share. Okay, am I up there? I can't tell. Yeah, they did give us these lovely jackets, kept us nice and warm, and we got something special. I don't know if you can see it, but the jacket came with a
Yep, we see
solar
it.
eclipse patch, special for this trip. So even though we didn't get to see the eclipse and we didn't cross the Antarctic Circle, it was a fabulous trip. Thank you.
Thank you, Elaine. That sounds like a great vacation, even when there's not
Made the
an
best of it.
eclipse. Yeah, nice science field trip sort of thing. And I had a similar experience, not in the Antarctic, of course, but went to an eclipse and it clouded up just as the eclipse started. But it was kind of cool, the red ring around the horizon and the way the animals reacted. Of course, there weren't any animals around you to react other than human beings. But thanks for the report. That's really great. And to all CFAS members, if you take a trip or go somewhere and there's even the slightest bit of astronomical tie-in, we would love to hear about it. Nobody's family wants to see their boring vacation pictures, but we are better than that. We definitely want to see your vacation pictures, and I'm not even going to call them boring because.
And Richard, you said
they're
have
not.
your pictures tell a story. I
Mhm.
think my pictures kind of tell a story.
They did. Yes. Very good. Very good. Thank you. So we've talked about the moon. We've talked about the moon and the sun. And Eric Hoin, our board member at large, is going to spend a few minutes on the sun. Eric.
Hey, how's everybody doing?
Hey.
I'm gonna take
Great.
us to a warmer climate here. And let me bring this up. All right. So last week I introduced Elaine after I did my presentation. So now it's my turn after Elaine's presentation. Few minutes with the sun. This episode is going to be Corona Part 2. Now we covered a lot, and this was back in October, believe it or not. So it's been quite a while, it seems to me anyway, since I did a presentation. I had a much longer presentation ready in case we were back in the planetarium, but so this will be the short version. And this is called Corona Part 2 because I had covered a lot about the corona. When we talked about the sun, we talked
Hey,
about
Eric,
different.
oh, never mind. I was going to say, I hate to interrupt, but your slides weren't all showing on the screen, but no sooner than I interrupted, it looks fine now. So I'm just going to
Okay.
go back to being quiet. Never mind. Pay no attention.
Alrighty. So, in talking about different zones and layers on the sun, we left it off with the corona. And so to follow up with that, just a short, the corona is the outermost part of the sun. It's the sun's atmosphere. Corona is another word for garland, is Latin, means garland, wreath, or crown. And while we were partying, middle of December, there was actual science release by NASA in regards to a gentleman I will show you on the next slide, but it has to do with the corona that we were talking about and the solar wind. And that gentleman is Dr. Eugene Parker, who's over at the University of Chicago. And in August of 2018, the Parker Solar Probe was launched. And Dr. Eugene Parker was the gentleman, a solar astrophysicist, who in the 1950s, he developed a theory about a supersonic wind coming off the sun. And he actually he's the one who discovered the solar wind. And from that, it's totally changed our understanding of the sun and interplanetary space. He's still with us. He's 94 years old. And this will be the perfect segue into my next presentation, which will be about the solar wind. So for right now, what I want to do is escape out of here. And NASA on December 14th there, we were partying at CFAS holiday party on the 15th. But shouldn't do that. You may miss something like important NASA articles or world peace or something. What I want to do is share this presentation. It's a 5-minute presentation by NASA in regards to, come on. Let me get this back up. Let me get rid of this. Okay. Can you see that? Can you see that presentation?
We just see your slides and
Okay.
we see the PowerPoint interface.
Okay, let me close that. Let me go back to screen share so I can get the proper program going. There we are.
This needs to go on your resumes, all of our resumes, Zoom expert.
Okay, here we go. Here, let's start that over then.
In August 2018 in Cape Canaveral, Florida, NASA launched Parker Solar Probe to touch the sun. After spending a few years spiraling closer to our star, the spacecraft has finally arrived.
It's amazing. Parker Solar Probe is touching the sun.
This is Noor Rawafi, the project scientist of the mission. He has been waiting for this moment since the beginning of his career.
This is a dream come true. One of the major goals for the Parker Solar Probe mission is to fly through the solar corona, and we are doing that now.
So what does it mean to touch the sun? To answer that, we need to look at the sun's structure. Unlike Earth, the sun doesn't have a solid surface. It's a giant ball of hot plasma that's held together by its own gravity. Solar material flows out from the surface, but around the sun, it's bound by the sun's gravity and magnetic field. This material forms the sun's atmosphere, the corona. Eventually, some of this hot and fast solar material escapes the core of the sun and gushes out into space as solar wind. The boundary that marks the edge of the sun's atmosphere is known as the Alpine critical surface. We didn't know exactly where this boundary was, but for the first time in history, a spacecraft has crossed it. Parker Solar Probe ventured into the corona, touching solar material still bound to the sun. The wispy corona is too faint to see most of the time, but it's revealed during total solar eclipses. For centuries, we've been studying the sun's atmosphere during eclipses because it's important for understanding how our star influences life in the solar system. But much about the corona remains a mystery.
Two of the most challenging scientific mysteries in astrophysics occur in a region that we call the solar corona.
The first mystery is about the temperature. The corona is about 300 times hotter than the photosphere, the visible surface of the sun below. Secondly, there's a constant stream of particles flowing from the sun known as the solar wind. It accelerates up to millions of miles per hour out of the corona, and we don't know how. Solar wind can disrupt our satellites and technology. To better protect them, we need to go where the solar wind starts, in the corona. So heading there has been a key goal of NASA's for a while. We first proposed the idea of sending a spacecraft to the sun in 1958. We didn't have the technology to withstand the journey until the 2000s. Since its launch in 2018, Parker has been heading towards our star. Then in April 2021, during Parker's 8th orbit around the sun, the spacecraft was around 20 solar radii, or 8 million miles from the sun's surface, when it crossed into the corona.
This is a huge milestone. It took us over 6 decades to come to this point.
As Parker enters the corona, Its whisper instrument took these images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the sun's surface. Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in solar wind, where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun. Here we see distinct cells. As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface. Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle though. Exactly how they form is still unknown. Over the next few years, Parker will keep looking for clues as it explores our sun, the only star we can study up close. The sun is also the only star known to support life, so understanding it is critical as we search for life beyond our solar system.
That will link directly with the question, are we alone with this universe? And that is one of the biggest questions for humanity.
So as you can see from that that information and that release, along with the animations, it's to me it's pretty exciting, you know, doing these presentations about the sun, and to actually have a spacecraft enter the corona with those kind of wind speeds, with all that going on in the sun's atmosphere, all those particles, photons, some plasma going millions of miles an hour, and the spacecraft actually surviving that. To me, that's just as exciting as landing a rover on the moon, or maybe going to the moon. I don't know if you can put it that drastically, since it's not a human endeavor, you know, where a human stands on the moon, but it's certainly an exciting discovery. So there's a lot more to come on that. And as I said, next we'll be talking about the solar wind and more about Dr. Eugene Parker and that spacecraft. That's it. Thanks, Richard. Thanks, everyone.
Thank you, Eric.
You're welcome.
All right, so we're going to wrap up with Mauricio, who's going to report on outreach activities. Mauricio.
Again.
Hey again.
All right. So, I mean, we haven't had too much pop up since our last event at the Flaming Arrow. My understanding is that I think Len was able to organize a few things with schools. He's been pretty active with I think the STEM nights. It's been a little bit difficult for me to get out there because they start kind of early, and I've got my work schedule, so I'm trying to figure out a way around that. We do have some. I saw that Leonard reached out for people to help out with some upcoming outreach at schools for STEM. So if you get his emails, well, I guess I would be taking over that. So him and I are supposed to be having a meeting this Saturday to sort of pass the baton. So I'll be handling that going forward. But so keep an eye out for any future emails that we've got coming out. But yeah, so aside from aside from the events that we're having these next 2 coming Saturdays at the planetarium, and a few upcoming STEM nights at schools. My understanding at the moment is that that's all we have going on with outreach, but so not much else to report.
Okay, thank you, Mauricio. And just a reminder, of course, the moon event this Saturday and next Saturday are both also outreach events held in conjunction with the planetarium. So that is a wrap for tonight. I'd just like to thank everyone for tuning in, so to speak. It's very it's great to know, we put this Zoom program together. I know it wasn't what a lot of people were expecting this month, but to see a good turnout, it's very gratifying to see that our members are still supporting us. And I will see you next month somewhere. Wednesday, February 9th, we will meet again here or in the planetarium or somewhere. But the show must go on one way or another. Everybody have a great night. Thank you, everybody who presented tonight for all of your hard work as well. And that's it.
Thanks, everyone. See you Saturday.
Bye.